What is also a very important argument here is the method argument. So by default, he will not fit a line to your data, but he will fit a curve to your data. If you want a line, you want to do linear regression, you will have to set method to linear model or generalized linear model. So LM or GLM. So what's the difference between linear and nonlinear regression? Well, in case of linear regression, you're going to fit a line to your data, a straight line. And there are two methods to do this. If your data is normally distributed, you can use what is called a linear model. The name explains it all, it's a line. Or when the data is not normal, like in the case of percentages, scores, counts, or just measurements that are not normal, you use this method, and that's a generalized linear model. It's a linear model, but it doesn't assume that the data are normally distributed. So two methods to fit a straight line. Nonlinear regression will not fit a straight line, but will fit a curve to your data. And here are also two cases, basically. Either you know what the curve should look like. For instance, you know for a fact that the curve should look like an S shape. Yeah, because that's what your data should be doing. So that means if you know what your curve should look like, that you can come up with a formula that describes what your curve looks like. And then you will do, yeah, it's very strange, linear regression. So you fit a linear model, but you give him a formula that is not linear. So LM here, the linear model, can do both linear and nonlinear regression. Another case can be that you don't know what the line should look like. Yeah, in that case, you do the lowest regression. So you see that here for the method argument, the things that come back are the things that I've shown on the slide. So you have the LM, yeah, which take care of linear regression for normal data, or nonlinear regression when you know the formula. So this LM here, the linear model, will be fit when you set method equal to LM. The GLM that you see here refers to what I've shown here. You want to fit a straight line, but the data is not normally distributed. Then you set method equal to GLM, and he will fit a generalized linear model to your data. And then we have the lowest here, that's the last one that I've shown here, this one. And that's the one that you use when you don't know the formula and you want a curve.